In Gifu University Graduate School of Medicine, a research group focused on a pigment cell named melanocyte, which affects on the color of hair and skin color. And recently, their work sheds light on the unexpected new mechanisms of hair graying and white spotting. Then, Dr. HITOMI AOKI will in detail explain about this.
I have always been involved in the research on melanocyte, which determines skin and hair color through the production of the pigment melanin. Melanocytes impart color to skin tissues and protect them from UV rays and other stresses. Hair graying or vitiligo is a condition in which some white patches of hair and skin appear. Though its cause is not known in detail, a non-basic therapy has been established. So in this slide, to study hair graying and the appearance of white spots on the skin through the mechanisms for development, maintenance, and disappearance of melanocytes, I created gray-haired mice by damaging their melanocyte stem cells with radiation and investigated this phenomenon at the cellular and molecular level. Melanocyte stem cells are located at the base of hair follicle, called the birth region. The accepted explanation up to now was that exposure to radiation eliminates the melanocyte-producing function of melanocyte stem cells, and this lack of mature melanocyte provokes hair graying. Indeed, radiation strikes dark hair and causes damage, but more detailed investigation shows some surprising facts. Melanocyte stem cells in the birth region did not lose their function directly as a result of radiation. Instead, the surrounding cells forming the optimal environment known as a niche, which protects stem cells, are highly sensitive to radiation, and melanocyte stem cells lose the ability to produce melanocytes through damage to this environment. As a result, hair turns gray. For the past 3 years, I have been conducting melanocyte research jointly with POYU, a manufacturer and a marketer of hair care products. And already we've been able to prevent hair graying to some extent at the animal experimentation level.
Thanks to collaborative research with Gifu University, we are able to clarify a variety of things. In the future, we would like to do our best to create products after checking safety.
Also, regenerative medicine is generating a lot of great interest these days. When working with ES cells or iPS cells, there's always a risk of genetic damage in the process of cell replication, which ultimately leads to cancer. I'm currently investigating a method that actually promotes the health of stem cells in the body, or sometimes even restricts the growth of stem cells. By doing so, there is a chance of reducing diseases such as malignant transformation. In conclusion, my research can potentially offer more practical benefit at a much lower cost. Thus, in the future, I hope to continue partnering with firms carrying out productive joint research in the hope of developing an efficient biological system that enables melanocytes to be more widely useful to society.